Hello friends, so today's question, a time dependent force F25T is applied on the lower block of mass M2, that is 20 kg, and is kept on a rough ground surface with mu2 as 0.5, and another block of mass M1 15 kg is kept over M2. The coefficient of friction mu1 0.8 between M1 and M2. Now it's two questions are asked based on this figure, taking G as 10. So first is, at t is equal to 14 seconds, the friction acting on the lower surface of 20 kg block is, and the second part is the graph showing the variation of frictional forces acting on both block is given by one of these figures, where one is represented 15 kg and second is being represented by 20 kg. So for first of all, let us draw a free body diagram for both the blocks, which will be helpful in representing all the forces. So this is your M1, which is 15 kg, and this is our M2, which is our 20 kg. On the lower block, external force F25T is being applied, and the friction between M1 and M2, coefficient friction, is given as mu1, which is your 0.8, and between the surface here it is given as 0.5. So because of this force 25T, which is being applied on 20 kg block, we'll try to move M1 block also towards the right. Let us suppose with the friction FR1, so equal and opposite will be acting on lower body, that is M2. Let us call this FR1 also, and there will be friction FR2, which will be acting on the lower block M2. So these are the forces which is acting other than the normals. Normal will be there. Okay, we will consider them later on. So time dependent force 25T is being applied on the 20 kg block. You can see, excuse me, time dependent force F is equal to 25T is being applied on M2, whose weight is given as 20 kg. First of all, we are going to find out that particular value of the time at which this M2 will try to move. Okay. So usually what is going to happen, this time t, which is given in, let's consider it in seconds, it's not mentioned here. So time, let's suppose, is being increased in the difference of 1 second, 2 second, 3 second, and t0 is the time when this 20 kg block is going to move. Okay. You can say, let at t is equal to t0, the block M2 tends to move. So under this condition, we can say our value of FR2 will be nothing but equal to mu2 35 G. Okay, let me So we have our two blocks like this. Second, so this is 15 and this is 20 kg. So we are going to have a friction here. This is called FR2. So we have mu2 as 0.5. So in the downward direction, a total weight of 35 G will be there, and there will be normal. Let us suppose that is called, we are calling it N. We can say our FR2 will be equal to mu2 N, and N is equal to 35 G. So this will be mu2 into 35 G. And it is being pulled by a force 25 T. Or we can simply say this implies that 25 T naught will be equal to FR2, and which will be equal to mu2 into 35 G. So from here we can find out value of T naught. T naught will mu2 is given as 5 by 10. This is 35 into 10. Okay, and divided by 25. 10 goes with 10, and this comes as 7. So we can say T naught is equal to 7. So at this particular value of time, that T naught equal to 7, block M2 will try to move. At T naught is equal to 7, block M2 will try to move. Okay. So it means now we can divide this value into two parts. In the first case, we consider case 1, when value of T is less than T naught. Basically means T is less than 7. So if T is less than 7, T is less than 7, FR2 will be equal to 25T, which basically means as this is going to increase, FR2 is going to increase in proportion. Or we can say if time is going to increase, FR2 is also going to increase in the same proportion. But under this condition, there is no acceleration or movement in the block M2. Okay. You can say this implies that no acceleration in M2. Okay. If there is no acceleration in M2, we can also say there is no relative motion between M1 and M2. There is no relative motion between M1 and M2, which also we can state it written as that. This implies that FR1 will be equal to 0. So these are the two important equations. Let us call this equation 1 and equation 2. So it means when time T is less than 7, the value of friction of FR2 will be directly proportional to 25T, and value of FR1 will be equal to 0. So we can partially draw the figure. This is our time T, and these are the friction. And let us consider this is T naught, which is equal to 7. So up till T naught, we are going to have FR1 as 0, and there will be a certain value of FR2. Okay. So this is our FR1 and this is our FR2. Now we can find out the maximum value of FR2 at T is equal to 7. You can say at T is equal to 7, FR2 will be nothing but FR2 max, which is equal to 0.5 into 35 into 10, or we can say this is divided by 10, moving the, so we get this as 175. So this value will be nothing but 175. Okay. So this is the partial. So we already bifurcated that at T equal to 7, the value of FR1 will be 0 and FR2 will be having a value of 175 newtons. Okay. So we already drawn the partial graph. Okay, so it means this won't be true, only will be between A and C. So we already found out the value of 7. Up till 7, this is our FR1. Okay, this is graph of FR1, which is having a 0 value, and up till 7, this is our FR2, which is having a value of 175. Okay. So either it will be A or it will be C. It can't be, up till now it can't be none of the above. At least it's not B, it's very clear, because it is giving some a parabolic relationship. Okay, and friction doesn't usually vary with respect to parabola, it is usually a straight line. Okay, so this was the first part. Now we can consider that case 2, for T greater than T naught, or basically means T is greater than 7. Okay. So under this condition, T is greater than 7, block M2 will try to accelerate, and also block M1 will also try to move along M2. So it means under this condition, this M2 will try to move with a certain acceleration, and M1 will also try to move along block M2. And they will move together. Okay, we can also say they both will move together until slipping starts between M1 and M2. Okay. So we assume let they are moving together with the acceleration a. Okay, we can say let M1 and M2 move together with acceleration a. So we can draw a. So this is 15 plus 20. A force of 25T is being applied, and there is a friction of FR2, and they are moving with the acceleration a. So we can write the equation that 25T minus FR2 is equal to 35A. From here we can find out the value of acceleration. Or we can say our acceleration is equal to 25T minus FR2 divided by 35. So this is the value of the acceleration. From here also we can write the equation for FR2. So you can say our FR2 will be equal to 25T minus 35A. So it means this equation is for t greater than 0. Sorry, t greater than 7. So for t greater than 7, the frictional force of FR2 will vary as per this equation. Okay. So it means we can further extend our graph So this was our previous strong graph. So this is our time t and this is our friction. So we have already defined t naught equals 7 and this is our FR1 and this is our FR2 and it is having 175. So now it will be varying by the equation 25t minus 35a. So let us suppose it is going somewhere like this. Okay, we can find the upper limit later on. Okay, now let us find out that what will be the equation for FR1. So we can say for block M2 FR1 is equal to for block M1 FR1 is equal to M1 into acceleration A. This will be a force acting on block M1, and if you put value of A, we get FR1. M1 is given as 15 and acceleration is 25t minus fr2 and divided by 35. And we also know for slipping, fr1 should be equal to fr1 max, and whose value will be coming as 120 Newton. Okay, so we can equate these two equations. You can say 15 upon 35 is 25t minus fr2 is equal to 120. And here we can solve it, and yeah, let us solve it further. So this can be written as 25t minus fr2 is equal to 120 multiplied by 35 divided by 15. And this can be written as 25t is equal to 120 into 35 divided by 15 plus fr2, or t is equal to 1 upon 25, 120 into 35 divided by 15 plus fr2. Now at this value of acceleration, okay, when you can say when m2 accelerates, or we can say moves, fr2 is equal to fr2 max. So you can put value of fr2, that will be coming as 175. So from here we can say t will be equal to 1 upon 25, 120 into 35, 15 plus 175, and this value of t will be coming as 18.2. Okay, so let us say this value of t is 18.2. So it basically means both blocks will be moving with the acceleration a up till this time. Okay, and so you can say at t is equal to 18.2, we can find out our fr1, which will equal to fr1 max, and that will be coming as 120 Newton. So it means obviously 120 will be lying somewhere here. So let me this way, and so this will be over 120, and up till after this obviously it is going to be a maximum value. And now we are left with the last part, that we are going to find out what will be this upper value. Okay, now it's clearly verified that both blocks will be moving at their maximum frictional value 120 as well as 175. Okay, from here we can say that this implies that both M1 and M2 will be moving or rather will be having the maximum friction values okay, so which basically means our FR2 max will be equal to 175 and FR1 max will be equal to 120 Newton. But the only thing is that the value of FR2 will be the result of relative values of FR1 max and FR2 max. Okay. So basically it means that this is our M1 and this is our M2. So the various forces that now we are going to have, let us suppose this is our FR2. So M2 is having a maximum frictional value of FR2 max, and here we are going to have a maximum value of FR1 because they are already moving at their maximum acceleration, and we already found out that at time t is equal to 18.2 the slipping between two blocks is going to take place. Okay. So we can confirm it here as the slipping is going to take place between M1 and M2 at t is equal to 18.2. Therefore FR2 will be equal to FR1 max plus FR2 max. So you can say our FR2 now, FR1 max is our 120 and this is 175. From here we can say that our FR2 will be coming as 295 newtons. So this will be our 295 like this. Okay. So this completes the graph. Let me draw it here again once again, sorry. T and this is our friction. So we defined value of t is equal to 7. At this particular value our FR1 was 0, so this is our FR1, okay. And at the same time our FR2 was having a value of maximum, that is 175, and it was having the equation as FR2 is equal to 2050. So this is our FR2. Next, we were able to find that the maximum value of FR1 is going to take place at t is equal to 18.2, okay, and that maximum value is our 120. So this is our 120, and this is the equation of your FR1. So this is FR1, and now it is going to have a constant value. Sorry, I missed it. Okay. So again we are drawing the same graph. So this is time axis. So we already defined first of all t is equal to 7. At this particular instant, when t is less than 7, FR1 value is 0, whereas FR2 is varying by the equation that FR2 is equal to 2050. Next value, we found out that at t is equal to 18.2, FR1 is going to have a maximum value of 120. So we already defined that this is 18.2, and at this particular instant it values maximum, that is 120. Okay. So this is our FR1 max. But in the same time period, the equation, or rather we can say the graph for FR1 varies by the equation 25t minus some acceleration, okay, 25t minus 35a. So this is our graph of FR2, and we also found out that the value of FR2 will be relative values of both FR1 max and FR2 max. Okay, their summation is coming as 295. This will be our 295, and after that it will be having a constant value like this. So this completes the second part. Okay. Now there is another thing asked, that at t is equal to 14 seconds, the friction acting on the lower surface of 20 kg block is, so we already know the value of FR, let me write it here, this is FR2 max. Okay, this value, this is because of the relative motion between the M1 and M2. Okay. If there would have no relative motion between M1 and M2, the graph would have stopped here. So we can say that the maximum value of FR2, which is equal to FR2 max at t is equal to 14 seconds, is given as 175 newtons. Okay. So A is the correct answer for the graphical representation, and for first part D is the correct answer, that is 175 Newton. So this completes the question. It was very interesting. In case of time dependent, the only focus should be that at what moment the block on which the force is being applied is about to move. If we are able to find out that particular time, then that time is going to differentiate, or we can say divide into two cases, less than and greater than. For less than, there will be a direct relationship between the friction and the force. As the force is being applied, the friction is also going to increase linearly. And after that, as the body is going to accelerate, the friction is going to have a different value depending upon the various configuration. As here it was a relative motion, so that's why it increased more. If there would have been only one block, 175 would have been a constant value. So this is the basic between your time dependent forces when applied on a block. Thank you.